So we are now live now. We are live now.
All right. Hello, everyone. Good afternoon, good evening, depending on where I'm watching from. Well, so I'm happy to be doing this. So my name is Justin Obi, a software engineer. All right. Currently, I'm contributing to Ethereum protocol development. So in Ethereum protocol development, we have different channels, different branches, and different departments. So I focus on the Trilight. All right. So today I'll be taking us through the journey, the introduction of blockchain, what is blockchain, the history of blockchain, proof of work, consensus, and proof of stake, and the rest. All right. So what is blockchain? So before I go into the introduction of blockchain and AI currently are the best of both worlds. Both of them are a lot of advances in those fields. And as far as I'm concerned, AI and blockchain are the main drivers of this tech revolution, AI and blockchain. All right, so by way of introduction or by way of definition, blockchain is a decentralized and distributed ledger shared in a decentralized manner, securely. So see it as a record, for instance, your Excel sheet where you have your rows and columns. So those are just transactions. Those could be transactions, those could be ledger or any data you can think of. So that data is mass shared among different computers. So whatever Mr. A have, Mr. B will have it. Then when there is a kind of dispute, that's where consensus mechanism comes in. So it is believed that everybody will have the same record, you know, so that when everything is going on, we'll have the same record, everything flows. So that's a typical ledger system on a blockchain. So it is decentralized. There's no monopoly of information or data. All right. So data is stored in blocks linked in chain. So what that means is the previous, it works with time, the previous time of the current, or the current timestamp of the current block is going to be linked to the next incoming block. So next incoming block is going to have the timestamp linked to it of the parent block, and so far and so as it goes down to the chain. So the incoming one we have also have the incoming block will have the current block timestamp. And most of all these things happens in splits of seconds. There's no room for manipulation. So and that was makes it secure. That's chain, linked, bound in time and all that. So data is stored in blocks linked in chain, making it immutable and tamper resistance. All right. So history of blockchain. Blockchain started way back 2009. On the lead was a Bitcoin. By then, when we are
Sorry,
here,
your voice is echoing.
is echoing.
Okay, it's all right now. You can continue now.
All right. So talking about history of blockchain, it started way back with Bitcoin in 2009. I believe most of us, when we heard Bitcoin for the first time, it was sounding like a scam project. So we are watching it with the eye we used in watching. We used to watch when internet was introduced. When internet was introduced, some steps to internet with one leg. So you are just testing the waters and all that. So the same way Bitcoin was introduced, some persons we are skeptical, or it's a scam project or scam tech. But from the look of things, Bitcoin has come to stay. Bitcoin has come to stay. So since 2019 now, that is almost 2 decades. It has gone through ups and downs, different market cycles, different tech changes. And here we are 2025. Bitcoin, I think as at early this year, December, we witnessed the all-time high. All right. Somebody said everybody should have a piece of Bitcoin. So a piece of Bitcoin is gonna be in Satoshi. You know. So if you could, if you have like one Satoshi, it could not amount to anything, but over time, with time, and I think I buy in that idea. Everybody should have a bit of Bitcoin, and a bit of Bitcoin, a unit of Bitcoin is Satoshi. All right, so then comes Ethereum in 2015. If you are into Ethereum community, Ethereum describes itself like the world computer. So what we mean by world computer, we don't mean the largest computer, we mean the world computer. So Ethereum somehow came to scale Bitcoin. Bitcoin was just mainly for transaction. You buy and sell, just a store of value. But then Ethereum came. Ethereum made the whole Bitcoin or made the whole blockchain stuff programmable. So you can now program it. Aside using it to store value, you can now program blockchain. You can now use it to do contract like, okay, I send this person on an errand. When this person delivers this stuff, release this amount of fund to this person. So that's basically what smart contract is all about. So Ethereum came with programmable feature for Bitcoin. All right. So that's what Ethereum brings to the table. And Ethereum has grown to a very massive garden. In fact, one of their selling proposition or one of their ethos, one of their community, like call it tagline is a big garden. So, and they are welcoming all manners of persons to cultivate the garden to make it a very robust place. And while you're cultivating, just imagine a garden. And while you're cultivating a garden, at the end of the day, it impacts on you. You get the value back. All right. So everybody is welcome to Ethereum. Ethereum is a very open protocol. You can do whatever you like, and that's where that transaction fee comes in. You can do whatever you like, but you're gonna pay a transaction fee to avoid spamming this system. You can build whatever you want to build, do whatever you want to do, as long as you're paying the transaction fee. All right. So that's basically the overview of the two blockchain histories. So how does Ethereum work? We have different branches of Ethereum, but right now on the high level, let's talk about smart contracts. So smart contracts is self-executing transaction. It's automated based on predefined rules. Like I said earlier, you could send somebody on an errand as a smart contract, and that's okay. When this person delivers, excuse me, when this person delivers this task, release this amount of money to this person. It has been predefined. In fact, we are entering into a system, into a society where a deterministic, that's the word, a deterministic society. Right now in Nigeria, so to speak, you could put your money in the bank and go the next day to get it, and they will plainly tell you that your money is not available. But it shouldn't be. And that's the problem this Ethereum is solving. They are bringing a deterministic society. What I mean by a determinist society is you know that A is always going to be A. You put in your stuff, it's supposed to stay 6 months. At the end of the 6 months, you're supposed to be getting 10 cents. 10 cents is what you're going to get in 10 months. There's no censorship, no middleman. So that's what I mean by a deterministic society. All right. So I also have another part of it, which is EVM, a global computing environment that executes smart contracts. So like just like we have for most of us that are into DevOps and setting up systems, we have what we call virtual machines. That's the technology that drives all these Dockers and all that. So in December now we have Ethereum virtual machine. Ethereum virtual machine can build on top of it the infrastructure that have the infrastructure available. So it's a global computing environment that executes smart contracts. So if we are not aware about EVM, let us take it from this platform today that is EVM machine. All right, I made mention of not spamming the system. In order not to spam Ethereum platform, there is what is called gas fees and transaction cost. Ethereum is an open place. You can do whatever you like, but while you are doing it, you need to pay something else. People will be spamming it. Introduction of gas fees also impacts on the security. Before you could write a script, let's assume that what we call DDoS. You are spamming a system that is supposed to, for instance, take like 100 users. You are now imputing, overwhelming the system. Like you're not giving the system what it couldn't or it can't withstand. So introduction of gas fee is making Ethereum secure, and it's making it not to be spammed anyhow. So gas fees and transaction fees required to execute transaction and prevent spam. So key concepts: decentralization, no central authority network run by nodes. Immutability, transaction cannot be altered once confirmed. Consensus, mechanism to agree on transaction validity. So let me take on this decentralization. You know, I don't know if you have heard of there are these people, they call them cyberpunks. A minute. Uh, Let me share this my. Okay, if you make a little research, there are a group of persons, they call themselves cyberpunk. There are people that they challenge system, centralized system, governments against censorship. Just like and their belief is that anything that is on the internet can be controlled, you can't govern them. So there are set of persons that are trying to use internet for greater good, for the public goods, and that's the on the principle they bet Ethereum. So Ethereum is decentralized, not controlled by any government or any system. Then there's what we call a diversity of network. We diversify the network. So simply what it means when a lot of persons are running their own nodes. So Ethereum welcomes individual to run separate nodes. So running a node means you're running a part of Ethereum, not really a part of Ethereum. You're running Ethereum on your machine. Just imagine Mr. A running Ethereum. He has his own copy of Ethereum. Mr. B has his own copy of Ethereum. C, E, and so on. So when all of us we are running Ethereum on our personal computers, it makes the whole system robust and strong. And also makes it more decentralized. So Ethereum welcomes individual to run node. You know, so immutability cannot be altered once confirmed. There are different stages of, for instance, when I post a transaction on Ethereum, we have what is called a, you know, we have had different states like confirming, finality, and the rest. So, but once it gets to this confirmed state, it can be changed. So consensus. So by the time different persons are running Ethereum node and there is a kind of funny behavior on the system, the majority of persons that have honest view about that system could, you know, agree on the transaction validity. So that what consensus is all about. A group of persons, you know, saying what they are, kind of showing their view about the system, how they are seeing the system. Like you could say, okay, this is the state, this is what Ethereum looks from our own point of view. Then the person around node B will say, okay, this is what Ethereum looks from our own end. So that what consensus is all about. At the end of the day, they now come to a common ground on the state of Ethereum. All right, so we have different types of blockchains. We have public, private, and consortium. I don't know if any of the, all I know about blockchain is the public. But me knowing about the public blockchain doesn't mean the other one doesn't exist. All I'm concerned is it's all about the public nature of blockchain. So we have the public, private, and consortium. Public are Ethereum, Bitcoin. Ethereum, Bitcoin are not only blockchain. We have Solana. We have many of them. Agorand, Mia, and many L1s and L2 blockchains. But for the time being, for the scope of these studies, we are just somehow focus on Ethereum and Bitcoin. All right, so we have public, private, and consulting. So public, open to everyone, decentralized, private, controlled by an entity, restricted with restricted access. The consortium, multiple organizations control the network. So use cases of blockchain. Nowadays, we have different use of blockchain. The one that's in vogue as we speak, yeah, we could use AI on the blockchain. You could write your AI agent and whatever and have everything sit on the blockchain. All right, so we have cryptocurrencies, supply chain, healthcare, finances. That is therefore a lot of the times I see people talking about once you mention about blockchain, what comes to their mind is cryptocurrency. All right, so cryptocurrency is just a microcosm of just a small part of the whole big picture of blockchain. All right, so blockchain is wide. All right, we could use blockchain for tracking of goods from production to delivery. Most of the times when we buy drug, normally see on the back of the drug to scratch it to verify the authenticity. But with blockchain, once that type of record is, you know, executed, once it is broadcasted, it is there for life. No more, it can't be tampered. So blockchain is a very good, it's a very good example of how like medicine could be used to show a tamper-proof use case. Then also have a healthcare, secure medical records. Once somebody comes to your organization to take a blood test or whatever, there's every tendency the person could, make friends with any of the employees there and alter a record. Not the same case with blockchain. So have the fight life finance, trading, lending, saving, providing liquidity, and all that. So those are the minor use cases of blockchain we could cover right now. There are a lot of them. There are a lot of use cases of blockchain. All right, going forward, we'll have Ethereum architecture and components. All right, so when you download the wallets and you create an account, we'll call that account EOA, externally owned account. So your personal account is likened or is termed EOA, externally owned account. So we also have contract account. When you create a smart contract, that contract, smart contract, originally an account will be mapped to it. So that is smart contract accounts, and there is a kind of a big difference between the two. Both of them they have different scope. All right. Then also have when you do send money from Mr. A to Mr. B, that is transaction. When you save a copy of record, that is transaction. So everything on blockchain is transaction. So sending Ethereum, interacting with smart contracts, you can all group them as transaction. So block and mining, how transactions are validated and added to the block. We made mention of consensus and all right, also validators. Validators are the people that, let's say, mine blocks on the Ethereum proof of stake mechanism. So on the proof of stake, we have validators. They are the ones that add the batch transactions. So we could have transaction A, transaction B. They could, so they have a kind of time window to add those transactions. So those transactions will now be called a block. So inside a block, we have transactions. So they have a time, an open window to have those transactions added to block, and they validate it and add it to the blockchain. All right. I don't know if anybody have questions so far. Yes, I'll go ahead and I think we are coming to the end. Before we call it a day, we have a consensus mechanism. So as at before 2020, around 2022 or thereabouts, Ethereum was still operating under proof of work. Proof of work is when they will send a kind of problem. So by the time you solve that problem, you must have kind of validated, confirmed the transaction. So in the proof of work mechanism, there is a puzzle a miner, then we don't have validators. A miner needs to solve to add a transaction, to the block. So that was the proof of work era. So the drawback of that era is characterized by heavy computational work. Heavy computational work, it involves a lot of, everybody want to go green nowadays. They don't want to be spending a lot of energy in this type of work. As a matter of fact, blockchain is at the forefront of green initiative. They don't want to be burning too much gas, releasing too much gas, to the environment. So I think that's the one of the motivation of converting Ethereum from proof of work to proof of stake. So in proof of stake, we have validators. So before you become a validator, you need to stake 32 Ethereum. So when you stake 32 Ethereum, you can now be called a validator. You can now be, you now be given opportunity to be adding transaction as block, and all that. Then there is also a penalty for a validator. When you're a dishonest validator, you could get slashed. Your 32 Ethereum, you could be penalized for maybe for not being online, for maybe confirming when something is green. I now say hey, it's white. When you is be that kind of behavior, there's penalty for such validators. All right, so we have delegated proof of stake, voting based on validation system, another mechanism, proof of authority, proof of history. We have different consensus mechanisms, but currently for Ethereum is making use of proof of stake. All right. Then my next slide will have a advanced blockchain concept and emerging trends. Advanced blockchain concepts and emerging trends. All right, so we have layer 2 solutions, roll-up sidechains to scale Ethereum. So there are different solutions. Ethereum. So in blockchain, there's what we call trilemma. In that trilemma have decentralization, we have scalability and security. Is so no blockchain has attained these three, no, three concepts or three aspects of blockchain. So you see that you go for security, you are very secured and you're scalable and you need decentralization, or you are decentralized, you are very secure blockchain, but you are not scalable. So for Ethereum is very secure, very decentralized, but uh, is lagging in the side of scalability. And that's where layer 2 solutions comes in to scale. So their job is to scale Ethereum. So where you are having costs, heavy pricey transaction on Ethereum, layer 2 tends to make transaction cost very cheap. So talking about scaling solution, we have sidechains, roll-ups, scale Ethereum. We all know about one of the roll-ups we have is Katesi. We worked with Katesi, where you could do heavy computational stuffs on the blockchain, like rendering. For persons that are building game, those who are into game building, they make use of heavy, computational, resource intensive technology. So those stuffs, if you want to build something like game on Ethereum direct, it's gonna cost a heavy fee. But a layer 2 solution has made it in such a way that you could build game on Ethereum and even at a very cheaper price. So that's what layer 2s are all about. They are there to scale Ethereum. Ethereum is very secure, very decentralized, but it's lagging in this scalability aspect of it. So interoperability means for different blockchain to talk to each other and interact together. All right, so projects like Polkadot and Cosmos enable blockchains to communicate. So communication is very important in the blockchain sphere. So that's what interoperability means: decentralized finance, lending, borrowing, trading without intermediaries, non-fungible tokens, NFTs. As at last 2 years, everyone was agog with NFTs. All right, so NFT means that part of the blockchain that cannot be divided. Once you have Bitcoin, why Bitcoin will have several satoshis, several units of satoshi. It can be divided into different units. Money, Ethereum can be divided half Ethereum, quarter Ethereum. You can have 0.00 Ethereum, 0.1 Ethereum, 1 Ethereum. It can be divided. So cryptocurrency, that type of asset is not fungible. It cannot be, it can be divided. So non-fungible tokens are, you own a piece of art, you could own an art cover. So in that art cover, if you have only one piece, that only one piece is for you. It can't tear you into two as, okay, this person take half, me, I take half. No. So that's what NFT is all about. So art, music, gaming items, you can buy land, you know, do whatever you want. Assets, the way we have it on the physical sphere, also have it on the digital space. All right. So future trends, we have metaverse, DAO, decentralized organization. All right. So there's this write-up I saw recently that said it's better to ask for forgiveness and permission. You know, so what blockchain, what they have been preaching is permissionless. You don't need permission to own assets. You don't need permission to involve in trading. You don't need permission from any person to do anything good you like. So most things are permissionless. I think that's the brain behind DAOs, decentralized autonomous organization. You can own a piece of an organization without taking permission from anyone, as long as you are playing by the rule of the smart contract. So community-driven governance, you can take part in organization of Ethereum, make decisions. So that what DAO is all about. You become part of another, in Web2, you can't just walk into any company and say, "Oh, I'm part of you guys," and start making decision. But it's very, very much feasible on the Web3 space. You can be part of the developers. Everything is open repos, repositories. Everything is, majority of the stuffs are open sourced. In fact, if you are doing a closed stuff, a proprietary software on a blockchain, that means you're not into blockchain business. You're not, if you're a startup, and your source code is closed, you will not get funding. So blockchain industry, they take open source, they take permissionless very serious. All right, so I guess that'll be all for now. I don't know if any person have a question.
Hello, guys. Uh, Thank you very much, sir, for the great session. So, if you guys have a question, you can drop a question in the chat. So I even got to learn some new things about blockchain today.
All right.
That's very good. So in the next, let's say 3 minutes, let's drop our questions in the chat. So while we are waiting for your questions, our next section will be happening on Saturday by 12 noon, because we observe that it will not be easy for everybody to probably on Saturday, people who are betting. So by noon, everyone can just join and we can have our live sessions once. You can follow up, and you can always watch the recording. You receive a mail with the recording of this session, the live recording. You can rewatch, and then if you also have questions, you can ask your questions in the Discord channel. I also drop the link to the Discord channel in this chat so that everyone can always join whenever you want to. All right, so that's the link to the Discord channel. Okay, in the absence of no questions, you can always ask a question in the channel. So thank you very much for joining us during these sessions. If you have anything you want to ask, any information you want to pass, you can reach out in the channels. We'll be also dropping tasks for you from as time goes on, so you'll be receiving everything in the channels. Thank you very much for joining us. It's good to have you around. See you on Saturday.